All right, so before we begin using R, we actually need to get it downloaded and installed on our machine. So I'm going into the Google search bar and I'm typing rcran, which will navigate me to the Comprehensive R Archive Network. If I click on that link, it will open up a page and you can see that I have different choices for installing R on my machine depending on your operating system. I'm running a Windows machine, so I'm going to go there. This is most likely what you will want is to install R for the very first time. I'm going to install the most recent version of R at the time of this recording, which is R 3.5.1. And so when I click on that, you'll see that it is downloading down here. And I'm just going to walk you through very quickly an install of R. So I'm going to hit run. It's going to ask me how I want R. I'm basically going to accept the defaults. So English, the end user agreement, it will store this in its own program file. I'm going to take all the different versions, both the 32-bit and the 64-bit. I'm going to accept the defaults. And if you want, you can create a desktop shortcut, but I'm not going to do that, and we'll see why in a second. Okay, my setup is complete, so I'm going to click Finish. And now I have R on my machine, but as I said in my introduction, the way we are going to interact with R is through RStudio. So I also need to make sure I have that downloaded and installed on my machine. So I'm just going to type in RStudio into the search bar. And we can go to RStudio Home. And what I ultimately want is I want to download RStudio. There's another link right over here for you to get. I want to get the desktop version of RStudio to run it on my desktop. And if I click on this little button right here, it will give me different choices. I'm going to take the free version. So I'm going to say download now. Again, we can make different choices for our operating system, Mac, Windows, Ubuntu, and so on. I'm running Windows, so that's my obvious choice. All right, so we're going to walk through the same steps here for RStudio and install it. And we'll just quickly go through the setup menus, and I'll just pause the video for a second while it's installing and come back when it's all done. Okay, so now that RStudio is installed, we can close out of this window and you can navigate to the icon for RStudio. You might have one on your desktop. You might find it under your start menu. I've got RStudio actually already loaded right here. So I'm going to click that open. And this is typically what RStudio will look like the very first time you open it. Now notice that it's different from what I talked about earlier, having this 4-window setup. And normally the very first step is you're going to be using, interacting with RStudio using this R script. So if you open up an R script window, this is a blank scripting window. So now we have this, again, 4-window setup, just like I was talking about earlier. And here you can see that this is where we're going to be typing our text and interacting with R. This is R itself. So this is the R console. So what we type up here will be sent to the R console and results will be displayed down here. And then just some other handy dandy things over here. Now that we have R and RStudio installed, one other thing that I want to show you is how I go about and manage my different files and scripts in R. And I do that with something called a project. So what I'm going to do is I'm going to go down here and I'm going to say that I want to start a new project. And when I do that, it pops open this little menu here, and I'm going to say, well, I want to start a new project, and I'm going to put this project in an existing directory. If I go to my desktop, I have a directory already on my desktop set up for this called Karma Basics of R. So I'm going to create a new project in that directory. So when I hit Create Project, it will sort of reload RStudio with this sort of new, fresh look. And again, I can open up a script window if I want to get that sort of 4-window setup that I like to interact with. Now, another handy thing about this project setup is the files that are in this directory related to R and RStudio will actually appear in this window. So what I have sort of pre-populated for this first lesson is our introductory lesson to R. So I'm going to click on that, and you'll see that that script sort of appears in my scripting window under here, Lesson 1, R Basics. So one other thing that I want to do before we get started is I want to adjust an option in here, which is just something that makes it easier to interact with R, especially when you're doing these sorts of workshops. And so if you go under Tools and you go into Global Options, under Code, there's this option to soft wrap the R source files. So I'm going to click on that, make sure that's checked, and I'm going to hit Apply, and then I'm going to hit OK. And the reason I want to select that option is you'll notice that if I make my window smaller, you'll see that my code that was sort of extending beyond that window gets pushed to a new line, but it doesn't really get a new line number down there. And so that just makes reading of the code and interacting with code easier, especially when it extends across a screen. So our setup for this first lesson is as follows. So I've got, the basic title of the lesson. Again, just a reminder that comment symbols in R are the pound or hashtag symbol. And again, R will ignore anything after that pound symbol on that line. So what I've done is I've created this sort of block at the top of the code that tells us a little bit about what are some of the functions that we're going to learn about in this file. And what I've done is I've tried to do that consistently throughout all the different code that you're going to get shared with for this course. And the other thing that I've done extensively as you just sort of scan through this code is I have commented it extensively. And the reason that so if you look at this code, you'll see that there's very little actual R code in here. Everything that's green are all comments. So R is ignoring everything that's green and paying attention to the blue, which is the actual R code. All right, so let's very quickly work through some of this code and see what's going on. So when we check out R, one of the first things we know is R is a calculator. So I've got 2 plus 2 here. And remember, this is my syntax window, and what I want to do is I want to take information from the syntax window and submit it down to the R console. So there are a number of ways to do that. My preferred way is a little keyboard shortcut. On PCs, it's Control-Enter. I think on Macs, it's Command-Enter. And you'll see that when I hit Control-Enter, it takes that line of code that I was at, line 19, submits it down here, and produces the answer right there. Okay. Other ways you can run that same line of code, you could highlight it and hit run, and that will also work. I just find the sort of Control-Enter very efficient to go line by line through a bunch of different code. Now notice when I do 2 plus 2, I get this result that has this 1 in square brackets. So the answer is 4, but I have this 1 in square brackets. And that in our language is what's called the index number. And all that means is that this answer 4 is in the first position of the result. Okay, so let's look at another example. Here I'm going to create the numbers 1 to 50, just doing that with a little colon. So now what I've done is I've created the numbers 1 to 50, and you'll see that at some point those roll on to the next line. And when they roll on to the next line, I get another index number here. So all of these numbers are in a single vector going 1 to 50. 1 is in the first position. 27 is in the 27th position. So that's really all this means. And your numbers may not match up mine. It's all going to be a function of how wide or skinny this window is. If I change the length of that window and I run 1 to 50 again, you'll see now 1 is in the first position, 20 is in the 20th position, 39 is in the 39th position. Okay. All right. So all we have done so far is we've just printed the answer to 2 plus 2, and we've printed the numbers 1 to 50. You can store the answers in an object. So here's an example of me storing the answers in an object. Here I am saying that I'm going to create an object called A, and A is going to get 2 plus 2. So this little less than symbol with the dash, the arrow pointing to the left, really signifies the word gets. So A gets 2 plus 2. When I run that line of code, again hitting Control Enter, you'll see that now in my environment up here, I have an object called A. And what is in A? Well, the number 4 is in A. Okay. Now notice when I do that, there's no result printed below. If I wanted to see what was in A, I can just type A and hit Control Enter, and it will print what is in A. Okay. Now notice that I can use that arrow pointing to the left, or I can use the equal sign. And both of them do the same thing. A gets the answer 4, B gets the answer 4, so they both work. But in sort of the R community, everyone uses this assignment operator gets in place of the equal sign for 2 reasons. One is that gets operator more accurately signifies what's happening. It's not really saying that A is equal to 4. It's really saying whatever is on the right side of that operator is going to go into the object on the left. So it's just going to replace what's there. If something was already there, it's not going to say, well, is this equal or anything like that. So the equal sign doesn't really signify what's actually happening in R. And also, people tend to like to use that equal sign later when referring to arguments and functions, and we'll see some examples of that in later lessons. All right, so far what we've done is we've created these objects A and B that have a single number. We could put lots of numbers in an object. Here I'm creating the object C. C contains the values of 1 to 50. Again, if I want to see what is in my object C, I can hit Control Enter on line 50, and it will print out all the values of C. Okay. So in my intro, I said that there are 3 basic statements of R in R, and you've already learned 2 of them. You've learned the comment symbol, you've learned the assignment function, the assignment statement, and the last key statement in R is a function. And functions basically take the form the name of the function followed by parentheses. Okay. So here's a very simple function, the print function. So the name of the print function is print, and then I have parentheses, and then what I'm doing inside those parentheses is I am providing arguments to that function. So what is an argument? Well, you can think about an argument as like the options for a function. You can also think about the arguments as like, well, what does R need to know in order to execute that function? So in this case, I say, hey, R, print. Well, in order to execute that function, R needs to know what I want to print, and hence I provide it with A. And so you can see that when I hit that, I get the value of 4. Okay, so in my print function, I'm supplying a single argument here, A. But functions can take multiple arguments, and again, we'll see examples of this later, but just to illustrate, here is a function, help. And I need to say, what do I want help with? Well, I want help with the print function. And again, one of the nice things about RStudio is that it opens up a little help menu over here, so we can take a look at what some of the values are for particular functions. And if I look, I can see that in my print function, I need to provide an argument x, and that x really means what do I want to print. But then I'm given other options that I can toggle on and off for different things that I'm printing. So I could specify more arguments in that function by following A with a comma and then changing the arguments here. And you can see that I can set an argument equal to something. And so when I said earlier that people don't like to use the equal sign in place of the assignment operator, it's because they like to use the equal sign in these functions to set argument values when needed. So with these arguments, some of them are set by default, and you don't need to specify them. So like with print, I don't need to specify anything unless I want to change one of the defaults. Okay, now another thing to note is that in R, there's actually always a default function running, and the default function running is print. So here is my print function. If I don't include the print function, I just say A. It's as if I said print A. So you can see that those 2 results are exactly the same. Okay. Another handy dandy function is the remove function, just the letters RM. And what this does is it removes objects from your workspace. So here I'm going to remove the object B, and you see that that cleans up my workspace a little bit. All right. Now, another thing that I talked about in my little introduction was packages. And I said that's really the secret to R are these packages. And there are different ways that you can install packages. So the simplest way is probably not the way I would recommend. So the simplest way to install packages is to click on this little package tab and hit install and just find the package that you want to install and provide the name of it and hit install, and it will go ahead and install that package. Now, I discourage this because I think we're better off putting the commands to install packages directly into our scripts themselves. So there's actually a function called install packages. So here I'm going to say, give me help on install packages. And you can see that there's a function called install packages that says, well, what packages do you want to install? And it gives you lots of options to change how or where you want to install those packages. Again, I mostly just stick with the defaults. What this looks like is if I remove this comment symbol on line 87, this is the function to install packages directly in my script. So if I run that line of code, you'll see that it'll do exactly what happened before, and it will install that package in my environment here. And you can see that it's in my user library up there. This you may not look exactly like my setup, but it should be somewhere most likely in this list. Okay. All right, now, in addition to installing packages, in order to actually use them, you need to make that package active. So there's a difference between downloading packages and making them available for use. And so that's really where the library function comes into play. The library function makes a package active so you can actually call functions in that package. So notice when I run line 94, I get a little checkbox here. That means that now I can call different functions in the psych package. And again, just to show you how useful help is, if I click on the psych package over here, it tells me all about all the different things that I can find in the psych package. So one of the nice things about R is there are a lot of built-in data sets for you to try stuff out. So here are some built-in data sets that happen to be at the top. But you can also look at a bunch of different functions. So one of the functions that might be interesting to you is describe, which provides basic descriptive statistics. And I can click on that and find out more about what I can do with describe by reading through the sort of help menu here. Okay. All right, so a couple other handy dandy functions. If I say library with no functions named, it'll just show me all of the functions I currently have in my library, and it pops open in that window. I never use this function because I can sort of check that out over here to see if I have things available. And the search function will show you which ones are active. So again, here are the ones that I currently have active. You can see psych is listed there because I made it active. Again, I rarely, if ever, use that because I could sort of scan through. This one's a little bit more useful because if you have a lot of packages and you just want to see which ones are active, you could see it a little bit more quickly with search. Now again, this distinction between having packages installed versus loaded is really important because if you don't have a package loaded and you are trying to call a function from that package, you will get an error. So if I run line 104, I get this error that says it could not find a function. And that's because that function is in a package called quantpsych that I have not made active yet. Okay. Now, I want to show you another little trick here is you can call functions in packages that aren't active. And the way you do that is by when you refer to that function, you actually have to also refer to the name of the package and include these two sort of double colons there. So name of package, double colon, name of function. And that will allow line 110 to run. So if I use this setup and I run line 110 by hitting Control Enter, you'll see that what it does is it prints out the z-score value for each of my 50 values, 1 to 50, like so. Okay. And again, why did it print it? Well, because that's my default command is like print the result of this function, because print is always sort of the default. Now, my basic rule, if you sort of read through my comments here, if I'm not going to use a package a lot, I might use the double colon, but if I am going to use a package a lot, I want to cut down on typing, so I'm almost assuredly going to install that package. Now, the other thing I want to do is show you a little shortcut trick to downloading and installing packages using a package called Pacman. So the first thing you need to make sure you have is you need to make sure you have Pacman installed. So hopefully if you went through the help menu, you've already got installed. If not, you should be able to run line 119 to do that. But if you have Pacman downloaded and installed, what I can do is I can run the Pacman function, and the Pacman package, and a function in the Pacman package called pload. And this basically says load this package pretty R. And what does pload do? Well, it actually does two things. It downloads pretty R, so it's like running install packages, and it makes pretty R active, so I can then call functions from pretty R. Here's another example. I can say, hey, Pacman pload pretty R psych quant psych, and I can click on that. And what it will do is it'll make sure all three of those packages are downloaded and that I can actually make use of them. One of the advantages of the Pacman pload approach is it not only can run both the install packages function and the library function at the same time, but it does something even more advantageous, which is it first checks to see if you've already got that package installed. So if you've already got that package installed, it actually skips that step, which can be really handy because some packages, when you install them, it actually installs a bunch of other packages along with it, and it can take some time, and again, you might not have internet access or want to do that. So if you've already got a package installed, it's completely unnecessary to install it again, and the Pacman pload approach prevents you from doing that. So it basically says, if I have this package installed, just make it active using library. If I don't have this package installed, well, run install packages, then make it active. So that's really my preferred approach for managing packages in my script. Now again, as a reminder, you can do all of these things like install packages, attach and detach packages, making them active and inactive, deleting packages, and so on, all with different buttons over here in RStudio. But again, I advise against that. What I want to try and do is I want to try and build code that is seamless and I can give to someone else and they can run it and it won't cause any errors. If I do things using these buttons over here and I don't put that into my code directly, then if I were to come back and run my code at a later time, it wouldn't work, or if I were to give my code to someone else, it wouldn't work. So I generally try and avoid those buttons, or if I use them, I take the code that they produce and I put them into my syntax itself. What's an example of me using a button and putting in my code? Well, here's the Pacman package. Imagine if I wanted to make it active. Well, if I click that button, you'll see by clicking that button, this is the R code that RStudio is writing and submitting to the R console. Well, I could actually go down here and copy that line of code and just paste it directly into my syntax, and then it's as if I push that button, but now it's built into my code, that button pushing behavior. Finally, I want to point out at the bottom of each of these script files, what I've tried to do is call your attention to some key things that I want you to remember from this lesson. So what do we have key to remember from this lesson? Well, the comment symbol is the pound or hashtag. The assignment operator means gets. You've got functions, and functions are the name of the function followed by parentheses, and the things that go in those parentheses are the arguments to that function. When you use R, one of the biggest things is you need to rely on these packages, and packages have two aspects to them. One of them is installing the packages, which basically downloads them onto your machine, and then the other is making them active, which is what the library function does. Again, I like to do both of them at once using the pacman package, which basically stands for package manager, and the pload function in there. And another handy-dandy function that we learned in this lesson is the remove function, which basically just cleans up objects from your workspace. So that's sort of our lesson 1, super basics in R. Now we're going to talk about a couple more advanced topics.